Good morning. Let us see the derivation tree. A derivation tree is a graphical representation for the derivation of the given production rules for a given CFG. It is a simple way to show how the derivation can be done to obtain some string from a given set of production rules. So, derivation tree is also called as a parse tree. A parse tree contains the following properties. So, these are very important properties of a parse tree. First one, root node is always a node indicating the start symbol. The derivation is read from left to right. The leaf node is always a terminal node and the interior nodes are always non-terminal nodes. Next is yield of a tree. The derivation or yield of a parse tree is the final string obtained by concatenating the labels of the leaves of the tree from left to right, ignoring the nulls. So, null will be ignored while writing the yield of the tree. However, if all the leaves are null, then the derivation is null. Suppose, for example, if the CFG is given by the productions S derives SS or S derives ASB or epsilon, one derivation from this CFG is AB, AA, BB. So, now this productions used at every step, you can show it using this notation, that is S derives SS. I start with the production S derives SS, and for the first S I replace by ASB. So, ASB and this S as it is. Next for S I replace by epsilon. So, I will be left out with ABS, and for this yes I apply ASB production. So, I will be getting AB ASB, and for this is again I apply ASB. So, I will be getting this, and now for this yes I apply epsilon, I will be getting the required string, that is AB AA BB. Now, this I can show it by writing the derivation tree like this. S derives SS. So, S is the root and it has the leaves SS which are here on the RHS. Now, for the first S, that is on the left, I have to replace this S by ASB. So, ASB will be the child for this S. Now, for this S I replace by epsilon. So, the string generated by this left subtree is AB. Now, for the right hand side, I apply the production S derives ASB. So, ASB, and for this again I apply S derives ASB. So, S derives epsilon. So, the right subtree generates the string A square B square. So, the string generated by the whole tree is AB A square B square. So, which is the required string. Next, leftmost and rightmost derivation of a string. So, leftmost derivation. In leftmost derivation, the string is obtained by applying the production to the leftmost variable in every step. So, every time the leftmost variable has to be replaced. In the rightmost derivation, it is obtained by applying the production to the rightmost variable at every step. So, suppose for example, let us say any production rules will be given by, suppose x derives xx or x star x or x or a over the alphabet a. Then the leftmost derivation for the string a plus a star a will be, I can start with x derives x plus x, and this first variable, that is x, I replace by a, and now the second x I replace by x star x, and this first x, from the leftmost, this is my first variable. So, this I will replace by a, and now this is left out with the only one variable x, that I replace by a. So, I got a plus a star a. So, at every step I am replacing the first leftmost variable. So, this is called leftmost derivation. Similarly, the rightmost derivation for the string a plus a star a will be x derives x star x, and for the rightmost symbol I replace first by a, and then for the leftmost x, that is the rightmost x, I replace by x plus x. So, now this x I replace by a, I will get this, and now this x is the only x which is the right x, that I replace by a. This is the rightmost derivation for the same string. So, these are the procedure or the steps which we have followed. So, first we have replaced x derives x plus x, then this left x I replace by a, then the remaining is this is the only x, so that is the leftmost x, so that x is replaced by x star x, and for this x I replace by a, and in the next step I replace this x by a. This is my LMD. And similarly RMD is shown where each of the right side variable will be first replaced to get a terminal string. Next is ambiguous grammar. A context free grammar G which has more than one derivation tree for some string which belongs to the language, or there exist multiple or more than one rightmost or leftmost derivation for some string. It is called ambiguous grammar. So question will be check whether the grammar is ambiguous or not. So you need to identify some string which can be generated using the given production rules with which has more than one leftmost derivation or more than one rightmost derivation, or it will have multiple derivation trees which are structurally different. So the solution will be here. Suppose I consider the same string, that is a plus a star a, and now we can show that the first derivation I can do it by this way, and the second derivation again this both are LMDs, leftmost derivation. I can start with x plus x or x star x, I get the same string. So the structure of the derivation tree, if you observe, they are different. So this is your derivation tree. So since the string a plus a star a has two different derivation trees, the grammar is said to be ambiguous. We'll stop for here and continue the simplification in the next video. Thank you.